Well, today is a big one, quadratic functions. We spent a whole unit on it 2 years ago. Um, and we're going to be doing the quick and dirty of it. So, um, forms of quadratic functions. So we have here in red is standard form, and that's ax squared plus bx plus c. Vertex form is over here, a times x minus h squared plus k. And lastly, in green, we have root form. To convert between these, we have a number of directions that we can go. So if we're trying to convert to standard form, then we're going to be consistently simplifying. No matter which thing we're starting with, standard form is simplified, so just multiply things out and combine like terms. In order to go from standard form to vertex form, we complete the square, completing the square. And to go from standard form to root form, we factor. What do each of these parameters mean? Well, I have a standard form equation here. The A I refer to as the tightness. I'm changing the tightness now. And if it's negative, then it's below, then it's facing down, and if it's positive, it's facing up. B is the slope on the y-axis. So here's a negative, on the y-axis. So here is a negative slope on the y-axis, and here is zero slope when we have the vertex is where the parabola has a slope of 0. And then if we make b positive, then it has a positive slope there. C represents the y-intercept. So that's all in standard form. If we look at vertex form, A still represents tightness. H represents the x-coordinate of the vertex. And K represents the y-coordinate of the vertex. And that's vertex form. In root form, we have two roots. And not every equation can be put into root form with real roots. But if we have two real roots, those are our two roots. So here we have it set up so that -3 and 2 are our two roots. A is once again the tightness. And if I change them to both be the same, then this root has a multiplicity of 2, meaning that that's the vertex on the x-axis. How do we find intercepts? For a y-intercept, we set x equal to 0 and simplify. That's pretty straightforward. Same thing with an x-intercept. We set y equal to 0 and solve. But how do we solve something that looks like 0 equals 7x squared minus 3x plus 12? There are a number of options that we have. We can factor. We can complete the square. We can use quadratic formula, or we can graph. Obviously, if we were looking for an x-intercept, we would probably not graph, because this one looks like it's not going to have a clearly obvious x-intercept. But we could use any of these options to find x-intercepts. To find a vertex, it depends on what form of the equation that we have. If we have vertex form, then it's pretty straightforward. H comma k is the vertex. From standard form, we use -b over 2a as the x-coordinate of the vertex, and then we plug it in to find the y-coordinate of the vertex. For root form, we would do because of the axis of symmetry, um, the vertex must be halfway between the roots, so we can take the average of the roots, and that will be the x-coordinate of the vertex. And just as before, once we have our x-coordinate, we can substitute it in to f to find out what the y-coordinate is. Lastly, how do we graph a quadratic function? Well, first we're going to start by finding the vertex using what we discussed over here. Then you'll graph another point and reflect across the axis of symmetry. So if you find that the vertex is here, and then you graph this point, you can say, okay, the vertex is going to be the vertical line going through the vertex is the axis of symmetry. Let's reflect this point across the axis of symmetry, and now we have our parabola. So that is our review of quadratic functions: the different forms, how to find intercepts, how to solve them, finding the vertex, and how to graph them. Thank you.